Lesson 1.9 looks at a statistics topic, analyzing data by using tables and graphs. You'll learn how to analyze data given in tables and graphs, bar, line, and circle, and determine whether the graphs are misleading. Why are graphs and tables used to display data? For several weeks after Election Day in 2000, data regarding the presidential vote counts changed on a daily basis. The bar graph at the right illustrates just how close the election was at one point. The graph allows you to compare the data visually. And this is a great comparison because you can see there's the height of the Chrysler Tower, which is almost as tall as the stacks of paper representing the number of votes, and the margin of difference would be only 1.6 inches. That's crazy. A bar graph compares different categories of numerical information or data by showing each category as a bar whose length is related to the frequency. Bar graphs can also be used to display multiple sets of data in different categories at the same time. Graphs with multiple sets of data always have a key to denote which bars represent each set of data. The table shows the number of men and women participating in the NCAA championship sports programs from 1995 to 1999. These same data are displayed in the bar graph. Describe how you can tell from the graph that the number of men in NCAA sports remained about the same while the number of women increased. Okay, the numbers for men's, actually it's kind of helpful looking at the table because it's more accurate. The men's numbers kind of jump around a little bit, but they're kind of staying right around that 200,000 mark, whereas the women's numbers in the table in particular are gradually, consistently increasing a little bit. So it's nice to have the side-by-side comparison with the actual numbers with the bar graph because we can kind of learn something from the numbers as well. To determine approximately how many more men than women participated in sports during the 1997-98 school year, is it better to use the table or the bar graph? Okay, since they use the word approximately, we could just use the bar graph. To determine the total participation among men and women in the 1998-99 academic year, why should you use the table? The question asks for an exact answer, not an approximate number, so we need to use the table. Another type of graph that can be used to display data is a circle graph. A circle graph compares parts of a set of data as a percent of the whole set. Percents in the circle graph should always have a sum of 100%. In everyday life, circle graphs are sometimes called pie graphs or pie charts. In mathematics, we'll refer to them as a circle graph. A recent poll in New York asked residents whether cell phone use while driving should be banned. The results are shown in the circle graph. If 250 people in New York were surveyed, about how many thought that cell phone use while driving should be banned? Okay, as a percent, we said that was 87% from the graph. So we need to find 87% of 250. We're translating 87% is a decimal, it's 0.87. Of always means times 250, and then we could say is, and we want to go is what number? Is always means equals. And if we grab a calculator real quick and multiply, 0.87 times 250 equals 217.5. Now it's awkward to talk about partial people, so we're going to say about 218 people said cell phone use while driving should be banned. Similar question, if a city of 516,000 is representative of those surveyed, how many people could be expected not to know, can't make up their mind, whether cell phone use while driving should be banned? Well, there were 3% that couldn't commit. So 3% as a decimal is 0.03 or 300ths. Of always means times. 516,000 is equals. And then used a calculator and I got 15,480 people. And that's how many people didn't know if cell phone use while driving should be banned or not. A third type of graph used to display data is a line graph. Line graphs are useful when showing how a set of data changes over time. They can also be helpful when making predictions. How would the change in enrollment between 1997 and 1999 compare to the change in enrollment between 1995 and 1999? Okay, at 1997 to 99, so in 97 we're at about, looks like 14.4 million, and in 99 it looks like about 14.9 million, which would be a difference of about 0.5 million. Okay, 99 we already said was about 14.9 million. 95 looks like about 14 point, we could call it 3. So it's a difference of about 0.6 million. So looking at our enrollment change from 95 to 97, it only changed about 0.1 million between the two. So I would think that 1/10 of a million would be a significant number, but I guess nationwide they considered that little change, so the differences in enrollment would be about the same. Why couldn't you simply extend the line on the graph beyond 1999 to predict the number of students to be enrolled in 2005? Oh, people want to. But the graph we have, the data that we have, is not large enough. The line would extend beyond the edge of the graph into the future, and we don't have enough information to know what will be happening then. Of course, 2005 is now the distant past, and we could look it up, but that kind of falls into the range of soft data instead of hard data. So far we have 3 different types of graphs. A bar graph is good to use if you want to compare different categories of data. Circle graph if you want to show parts of a whole set of data, and line graph shows change in data over time. Graphs are very useful for displaying data. However, graphs that have been constructed incorrectly can be confusing and can lead to false assumptions. Many times these types of graphs are mislabeled, incorrect data is compared, or the graphs are constructed to make one set of data appear greater than another. Here are some common ways that a graph may be misleading. Numbers are omitted on an axis, but no break is shown. The tick marks on the axis are not the same distance apart or do not have the same size intervals. Or if the percents do not have a sum of 100 on a circle graph. So we'll use the graph below to show his algebra grade for the first 4 reporting periods of the year. Does the graph misrepresent the data? Well, we've got a nice equally labeled scale here and here. And he's plotted the points. He started off with maybe, I don't know, 95, maybe 85, 80, 70. Okay, the short answer is yes, because it makes it look like it's not much of a decrease, and it is. The horizontal axis is spaced too far apart. It makes it appear like less change than it is. And of course, with the wonders of technology, that's easy to change. So suddenly, when I just squeeze the graph together a little bit there, it looks like a pretty significant drop. Other suggestions: the intervals on the horizontal axis could be the same as the intervals on the vertical axis. You could also include a break or an interruption on the vertical axis and start the intervals at 50 and increase by 10s to represent the drop in his grade a little more clearly. Okay, so in overview, bar graphs are used to compare different categories of data. Circle graphs are used to show data as parts of a whole set of data, and line graphs are used to show change in data over time.